right, welcome back. So on this episode, we're going to talk about transformation, and we're going to do one that's kind of like complicated because there's a lot that's going to happen. I've already graphed my parent function, f of x is equal to x squared. Let's just call this one h of x, and h of x is going to be equal to negative 1/2 times x minus 3, and it's squared, and that's negative 2. Now let's talk about the transformations that are happening here. The a value is equal to negative 1/2, and the h value is equal to positive 3, and the k value is equal to negative 2. Okay, so that is when we talk about the absolute value of negative 1/2, okay, that is less than 1, so that's going to give me a vertical compression. So that means that's going to become more flat. So, and you'll see visually when we start graphing it. All right, and then our negative, we have negative 1/2. That means that we are going to have a reflection. Okay, and we also have a horizontal shift to the right, 3 units. And then we have a vertical shift down 2 units. Now this relationship here, this is all related. This here is related to where our vertex is going to be. Okay, now if I look at this, my h and my k, my vertex is going to be at 3, negative 2. So I'm going to go 1, 2, 3, down 1, 2. So we had a vertical shift to the right, 3 units, and a horizontal shift to the right, 2 units, 3 units, blah. And then we're down 2 units. So, okay, but now that's that horizontal shift, and the vertical shift, but now we need to talk about the a value because that's going to affect how narrow or wide our curve is going to be. So let's talk about what happens when we put this in a table. Okay, if I plug in the point, so let's go and make our table. And we know we have a x and y. And let's see, we know we have our vertex is at 3, negative 2. Okay, and we know it's going to be going the opposite direction. Okay, so if I have, and if x is, let's talk about potential values that we want. If I say x is equal to, let's see. So let me go here to my calculator. I need to second quit. Okay. So if I let my value equal, let's say, on this side, so let's say it's going to be equal to 4, okay? If I let x equal 4, that's going to be 4 minus 3, which is going to give me 1, okay? 1 squared is going to give me 1. Then I'm going to times that by negative 1/2. So then negative 1/2 minus 2, oops, it's going to give me negative 2.5. But if I try 5, now we're going to stop here. I'm going to try one more. So let's say I have 5 minus 3. That's going to give me 2. 2 squared is going to give me 4. Well, 4 times negative 1/2 is going to give me negative 2. And negative 2 minus 4 is going to give me negative 6. So that means I don't really want to use this point here. I want to use 5, negative 6. You're still going to have the symmetric pairs. This is still your vertex, 3, negative 2. So if I go over here and I go 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5, 6. That's going to put a point there, okay? And then let's say I have the point, so let's try, instead of saying 2, let's skip one more, and let's say 1, okay? So if x is 1, then that's going to give me so that means that would be negative 1/2 times 1 minus 3 squared minus 2. That's going to give me negative 1 squared times 1 minus 3 gives me negative 2. That's going to be squared minus 2. Again, that's going to be what? 6. So I'm going to go over here and I'm going to go 1 and then 1, 2, 3, 4, 5, 6. Now, if you notice, my graph from the parent function, I didn't go right 1, down 1. I went right 2 and then 1, 2, 3, 4. So I have a much wider curve than I originally had. Now it's a little bit easier to see what happens. Let me see if I can pull this up and not do the negative. Let me see. Where is my, not that one. Let's go ahead and do this one. That's fine. Yes, yes, yes. Skip. Okay, will it rotate? Nope. Dang it. Okay, I don't want to use that one, so that's a bad one to use because it won't rotate for me. Where is my... Sorry. There it is. Oh, this is the one I wanted to look for. Okay, so I'm going to graph my parent function. Y is equal to x squared. Then I'm going to do it without the reflection first. And I'm going to change the color. Let's do this one pink. Okay, because I like pink. So we're going to have the transform function, and it's going to be alpha y equals, and we're going to have 1/2. And then we're going to have x, and then we're going to have x minus 3. And we're going to square it. And then we're going to have minus 2. Okay. Let's see. Even better, I'm going to take this out first. And I'm going to take that out. I'm still going to leave that, and then we're going to graph it. Okay, so the green one is the parent function. The pink one is the one that we transformed a little bit. We made our a value 1/2. Okay, now I'm going to go back to my a value, and we're going to change that to be a negative. Okay, so now, as you can see, and now reflected it. Everything, it's still wider, and we reflected it, okay? Now we're going to go back, and we're going to shift it. So we're going to say minus 3. And then we're going to also say minus 2, okay? And we're going to graph it. So as you can see, it shifted it to the right 3 units and down 2 units. You can't really see it. There we go now. That we're good. And it made it much wider. So those are the transformations that would happen. And we graphed it on here. It's a little bit more visually stimulating on the graph because, you know, this is just points that we put, and the graph is much cleaner. So hopefully that helps a little bit on transformations, and we will see you in the next video.